And I'm Arthur's dad, Matthew.
And today we found something really cool.
We found a really cool old analog meter, and we came up with a really cool project, something to make with it.
And we really want to show you it.
So stay tuned and we'll show you what we found. So this is our meter, and as you can see it's pretty big. So the way it works is there's a little dial, and on the back we've got two inputs, and as you apply and put this into a circuit, based on the current of the circuit, it will move the dial back and forward. So if you're designing a circuit for this to work in, and you're trying to figure out, okay, well, what's the maximum amount I'm going to put into this circuit that will cause the meter to peak all the way to one side, you need to figure out what's the maximum amount of current it will take. And in this case, it's 1 milliamp. So in other words, if this is in a circuit and you put 1 milliamp on it, it will peak the meter. And anything less than that will appear somewhere under that.
So we were thinking what to make with this thing.
And then we got a really good idea about a project to make with it.
So we found all these batteries in the drawer, and we needed to test them. So we thought we could make a battery tester with this thing.
Okay, so we put together a circuit plan here, and as you see, we have our 9-volt battery here that is then connected to our analog meter. And as you see, to peak the meter, we need 1 milliamp or 0.01 amps. And then we put a resistor in here to calibrate the current to make sure that if this is 9 volts, then this will be 1 milliamp. So to figure out the value of the resistor, we used a law from physics called Ohm's Law. And what it states is that the resistance of a circuit is equal to the voltage divided by the current. And since we know the voltage is 9 volts, and we know the current is 0.01 volts, right, we can figure out very quickly that the resistance is equal to 9,000 ohms, or 9 kiloohms.
So you can see on the bundles of resistors, we have 8.2 ohms and 10 k ohms, but no 9 k ohms. So what we did is we put two 4.7 resistors together, and we made about 9.
So as you can see, we're testing these out, and they're not quite 9K exactly, but they're close enough for rock and roll, 9.2 kiloohms. So we're going to use these in our circuit to approximate that 9K resistor.
So what we did is we got some handy-dandy alligator clips. We just hooked them on to these, and it doesn't matter which side. So then we just put one of them on this side of the 9K resistors. So then we put one of these on this part of the battery. So when we touch this to this part, it should go to about 100. So ready, set, go. Yep, got to about 95. So then we found this old cruddy battery in a drawer. We really want to test it. So let's see. Oh, this is a very bad battery. We should not use this one.
And the cool thing about this is we could make a switch, and we could, these little C, D batteries, or even AA or AAA, they're 1.5 volts. So if we plug that back into our circuit, we could even design a way to test these easily with the same meter. We just need a different value resistor. So that's our cool project we built with this meter.
So please subscribe and leave a like. That will help us a lot. And bye.